Hi everyone, and welcome back. We're in week 2 now, and this is going to be our first content lecture in this class. This lecture focuses on some of the foundations of theory and science. And in doing so, we'll be talking about some of why you guys are taking this class to begin with. So theory, science, research methods, all these things really come down to generating knowledge. And so what we're going to be talking about in this class is how we can generate knowledge. Well, what do I mean by that? I just mean how we learn things about the world. Right? So in order to exist in the world, to do a job, to make decisions, to know what policies to support, we need information. And we need to get that information somehow. And so for now, I just want you to think about where your knowledge comes from now. Right? All the things you know, how do you know them? And I'm going to guess that a lot of your knowledge comes from non-scientific sources, because that's true for most people about most topics. A big place that knowledge comes from is personal experience, right? So you live in the world, you experience things, and those things add to what you know about the world. And as an example, a lot of what you know about being a student probably comes from your own personal experience in being a student. You didn't have to look up what it means to be a student and read a lot of articles about it. You're just doing it, and so you know things about that. Another source of knowledge is often tradition and culture. So we learn things from the people around us, and many of those things are often considered common knowledge or truth. We also learn things from specific authority figures. And you might be watching TV and you see someone with a white coat or a doctor in front of their name come on, and they say a bunch of things, and well, that's someone to be believed. We also learn things from politicians, from teachers, from other people who hold positions of authority in our lives. And that's pretty common. We also learn things from the media. So I already mentioned TV, but every piece of media you consume can give you some amount of knowledge. And it's telling you things about how the world is. And more. So this is obviously an incomplete list of the places that we can get knowledge about the world, but when you really think about how you know a lot of the things you know, you'll probably realize that a lot of them come from non-scientific sources, or at least scientific sources that are filtered through some of these other places. So either authority figures or media or the people around you, or your own experience. And for the most part, non-scientific sources of knowledge will get the job done. Not everybody needs to be a scientist and do really scientific work in order to learn what they need to know about the world. But in some cases, it turns out to be really helpful to take a more scientific look at things. And this is one of my favorite examples. So this graph here shows media coverage of the drug issue from 1986 to 1992. And what you see is that in some years, the news was talking about drugs all the time. Drugs are such a big problem. And so we see there's a big spike in roughly 1987, a big spike in 1990. And just looking at this graph, you might think, wow, drugs must have been such a problem in 1987 and 1990. The problem is, though, that a source like media is not always a great source of knowledge because it doesn't always reflect the underlying truth. And what you need is a more systematic and data-driven way to find that. So let's look at this graph of the actual incidence of drug use in those years. Pretty different, right? And if you were to just rely on what you learned through the media, you might have a pretty different picture of what was going on with drug use in those years. So this graph shows pretty clearly that from 1986 to 1992, drug use declined. And that's it, that's the whole story. But it's a story that you'd miss if you only focused on media coverage of drug use. As it turns out, there are often a pretty consistent set of problems that arise when we only rely on non-scientific sources for our information. And in saying this, I'll stress again, most of the time, most of us are relying on non-scientific sources. Not everybody needs to be a scientist all the time, but being aware of some of these biases and issues that arise when your information comes to you in a non-scientific way can also be helpful, because it makes you more aware of what's likely to be true and what's not. So a big one is inaccurate observation. And most of the time, most people are pretty busy doing lots of different things in our lives. we're not 100% focused all the time on making observations about the world that are completely accurate. And your sense of what's going on around you is often going to be influenced by the things that are happening in your own life, how much attention you're paying to them, and so on. So you could imagine that it's 1987, you're busy, you're working a job, maybe you have a family, the news plays in the background every once in a while, and you just hear the word drugs a whole lot. That might lead you to think that the drug problem is really big in that year. And that wouldn't necessarily be an accurate observation, but it would be a pretty common scenario, and that was probably true for a lot of people. Related to that is the idea of overgeneralization. And overgeneralization is when you take a couple of instances or anecdotes and assume that they're much more common than they are. So as an example, if you walked outside every day and there was some kid smoking a joint, you might think, wow, so many kids are doing drugs these days. But really, you'd be thinking about that one instance that you saw over and over and over again. Another thing is selective observation. And selective observation is something that happens when you already have a picture about what the world is like, and then you only pay attention to instances and scenarios that fit with your view about how the world is. So let's say you believe that drug use is completely rampant among teenagers. 99 out of 100 teens that you see in a particular day are not using drugs. As you're just walking around, going out through your life, you see teens on the street, you see teens at the mall, you see teens walking to school, whatever you're doing, and they're not using drugs. But you see one who's using drugs and you think, wow, teenagers sure are using drugs these days. And that's something that we do in a lot of different areas of life. We pay attention to the things that already fit with the worldview that we have. Which leads us to our last problem with non-scientific sources, which is that often our view of what's true is influenced by our pre-existing beliefs and ideology as well. And they've done some interesting research showing that people will pay much more attention to facts that fit their worldview and will find reasons to argue with facts that don't fit their worldview to begin with. And it's something that we do completely unconsciously and without even thinking about it. And I recommend clicking through that link. It leads to an oatmeal comic, which I don't think is cool these days anymore, but it does a really good job of explaining how our brains can really automatically just ignore information selectively if it doesn't fit with our worldview. Again, so I recommend clicking through that link. You can pause me if you want or come back to it later. So we talked about some problems with generating knowledge in non-scientific ways, and ways that it can lead to an inaccurate picture of the world. So let's talk about what it means to actually generate knowledge using science. What separates science from non-scientific methods for generating knowledge is that science involves a careful and conscious use of observation and logic. In other words, we're not just going about it haphazardly, as we usually do, and letting information filter in. When doing science or research, you are very carefully and consciously trying to observe things in a systematic way that won't be as susceptible to some of those biases and problems we talked about before. There's also a focus on using logic. So rather than letting our unconscious brain do the work, we really try to focus consciously on making sure that we're drawing the right conclusions from the information that comes to us. A big part of scientific knowledge also is that there's a focus on what is and not what should be. In other words, we want to know what's actually going on without letting our beliefs about what should be happening influence our understanding of the world. Very much just the facts. And finally, a key to generating knowledge via science is to understand the rule and not the exception. So let's say that most kids aren't using drugs, except that one kid who always sits right outside your door. We want to understand the rule. We want to understand what most people are doing and not base our conclusions on exceptions that we might hear about or see or so on in our lives. And as an example, I sometimes like to use my grandfather. So I want to think you guys to think for a moment about the relationship between drug use and age. And do people who use drugs when they're young keep using drugs when they're older? Well, if you ask me to answer that question, and I was going to go about this in a non-scientific way, I might think about my grandpa. And my grandpa used a lot of drugs when he was young. He uses a lot of drugs when he's old. I'm pretty sure he's still growing weed in his gated community in Florida, trying to go into business with my brother. It's a whole thing. Gonna see how that goes. But anyway, if I were just thinking about this and not trying to go about this in a scientific way, I might think about this example of a person who used a lot of drugs when they were younger and continues to use drugs in their old age. And with this example, I might think, well, it seems like people who use drugs when they're younger also use drugs when they're older. And that would be a reasonable conclusion to draw based on this one anecdote and one example that I have. The problem with that, though, is that I'm focusing on the exception and not the rule, and I'm not carefully and consciously trying to think through the examples where this doesn't happen. And so if you take a look at this graph, which comes from criminological research, and again, you might need to move my head around, this graph shows the relationship between age and crime. And it's labeled generically crime, but if you look at graphs focusing on drug use, it shows the same exact pattern. And crimes like drug use peak in teenage years. So you can see on the x-axis there, its age is increasing, and on the y-axis, crime is increasing. So drug use peaks in people's teenage years, and then as people get older, more and more people stop doing crime and stop using drugs. So there are some who do, some like my wonderful grandpa, but most people don't. Also, I always like to think it's funny that I told my grandma that I talked about her real estate slogan, and my grandpa said, "Do you talk about me in your class?" And I was like, "Nope." So enjoy my fun anecdotes. All right, so now we're going to talk a little bit about types of scientific research. And here we're going to be talking about broad categories of generating knowledge in a scientific way and how they differ. So one of the big divides in scientific research is between quantitative research and qualitative research. And the key distinction between these two is the use of numbers. So quantitative research is all about numbers. We're trying to quantify or count things. We're trying to understand statistical relationships between variables. We're doing lots of things that involve putting numbers to different phenomena. Qualitative research is the opposite. And here we're trying to understand things in a way that is not numerical. And often qualitative research involves doing interviews or doing field observations where you're focused more on the little details of things that are going on. So quantitative research is numbers focused. Often it takes the shape of survey research or research using records or data, anything where you're putting together a whole lot of numerical information about something, crunching the numbers, and drawing some conclusions from it. Qualitative data, on the other hand, is non-numerical, often takes the form of interviews or social observation, although there are some other things that we'll talk about later that it can be, and often involves a focus on a few specific cases that really dig into the details. Another type of scientific research, or another distinction that you can make in types of scientific research, is between deductive and inductive research. In deductive research, you're starting from a broad idea and you're testing that idea using data. And I'm going to go through examples of each of these in a minute, so for now I'm just going to give the definitions. Inductive research involves going in the other direction. With inductive research, you're going to look at a few examples and try to think about the broader ideas that those examples suggest. So deductive is going from big ideas to more narrow tests of those ideas, and inductive research is going from a few examples to bigger ideas that can then be tested. A final category a set of categories that research can be put into are nomothetic and idiographic. And nomothetic research is focused on the big picture. We want to explain things in a general sense in the simplest way possible. Idiographic research, on the other hand, is focused on the little picture. We don't want to explain big things about large numbers of people with very simple explanations. With idiographic research, we want to look at a few cases or a few examples and really dig into the details and understand the who's and what's, where's, and why's and exactly how everything is happening. So nomothetic tends to be not very detail-oriented, but very broad, whereas idiographic research tends to be very detail-oriented, but also very narrow. And in talking about what these things, you end up with trade-offs with each of these kinds of research. And I love searching for stock footage of things like people on seesaws because this is what you get. But with all these different kinds of scientific research, you get a seesaw between generalizability, or how much can your results from your research apply generally to the world and to settings outside of your study setting or to populations outside of the particular one that you're looking at. But what you sacrifice when you have generalizability is detail. If you have one big explanation that can apply to a lot of things, chances are it's not going to be that detailed because when you actually look at a lot of things, there's often little variations in the details. On the other hand, if you have a lot of detail, and you can imagine those words flipping around right now, if you have a lot of detail, you lose generalizability. For example, if you know everything there is to know about the workings of a gang who lives in Newark and you've talked to all of them, you know their whole life stories, you know the people, you know the hierarchy, you know their grandmas, you know their moms, you know where they went to school, you know their favorite sandwich place. You can have a lot of detail and it can be really rich and really useful for understanding those processes. But you can't be sure that that detail would apply if you were to, say, look at a gang in Tucson, Arizona, with different people, different structure, different family, different sandwiches. So with all these kinds of research, you get useful information, but there's often a trade-off the closer you are to one end or the other, whether quantitative or qualitative, deductive versus inductive, nomothetic versus idiographic. There's often a trade-off in terms of how much generalizability you have versus how much detail you have. All right, so I mentioned there would be an example, and here's our first example. Let's think about nomothetic research. Here we're interested in the big ideas and in understanding a phenomenon using a few simple rules. So let's keep going with this example of age and crime. And this graph shows what I talked about before, which is that most people only offend in their adolescence, but a few are life course persistent. And we as researchers might be interested in understanding why people offend while they're getting older and what factors are associated with being a life course persistent offender. If we wanted to do this, we might take a large sample of people who are seniors and look at some factors that we think might influence offending. And here we might think about what seems logical or reasonable to be big explanations that could potentially keep people offending as they get older. And we might think about something like socioeconomic status, cultural context, and work history. And we're just going to start with those. So we've identified a few characteristics that might be common among life course persistent offenders. And we're going to look at this using a big data set of a whole lot of people in different situations. And in doing so, we could answer the question of what are some characteristics that older offenders usually have in common. And we'd be using a lot of data with a lot of different people in it. So if we found that these things were important, and by the way, I made all this up, so don't cite this for anything about actual age and offending research. But if we were to find that these things mattered in people's old age offending, we'd have an answer that we could be pretty sure would generalize pretty well because we knew it was true among a really, really varied and large group of people. But a limitation would be that the explanation is very broad and also incomplete. So we've identified a few things that might be important, but we absolutely have not identified every single thing that might be important. And here with nomothetic research, we're looking for some general rules, but we're not looking for a full explanation. So we get generalizability, but we lack detail. And in this example, I'll note that this is also quantitative. So in this example, we'd be taking a large sample of people, looking at these different characteristics that they have, and essentially tallying up what shows where and looking for statistical relationships in the data. So that would be quantitative research. This would also be deductive. So we'd be going from general ideas that we have and testing it in a specific group of people. Our general ideas are that SES, cultural context, and work history might influence offending into old age, and we'd be looking at those more general ideas in a sample of people that we selected for our study versus going in the other direction. We could also do an age and offending study that would be more idiographic. So let's say that we don't want to just rely on the ideas we might have had to start and test those ideas to begin with. We want to get some more detailed and rich information about people's experiences and use those to understand the phenomenon a little bit better. So an example of an idiographic study on old age offending, we might take a deep look into a few older offenders' lives, including their childhoods, their experiences with the justice system, their relationships with their family, their drug use, their work histories, their hobbies, their environment, their friends, and anything else we could think of or that they could tell us that could shine some light on their offending behavior in old age. And then we would use this information to get a more detailed picture of how the people we talk to continued offending into old age. And this would answer the question of why some people keep offending into old age. And we'd have enough detail that we could be pretty sure we have a good answer about these particular people. The problem is that our study would lack generalizability. So we might have a really, really good idea of why some people keep offending, but their experiences might be completely different from a whole other group of people who offend into old age, and we'd have really no way of knowing that. Also to note, this example would be an example of a qualitative study, so it would be not numerical. We'd be probably interviewing these people, maybe spending some time in the places that they spend time, but we wouldn't be crunching a whole lot of numbers about a whole lot of people. This would also be an example of inductive research, and most likely we'd go into this looking at these specific cases and use the information that we could get from this kind of study to think about more general ideas that could be the case. And so the nice thing about research and these idiographic, qualitative, inductive studies versus nomothetic, quantitative, and deductive studies is that they balance each other out really well. If you do research like this, idiographic example, you can understand how people's lives work, you can get some really rich insight, but then you can use that to form ideas later that can be tested in a broader and more nomothetic way. So if we were to, for example, find out in this study that the friends that older people have are really, really instrumental in whether they keep offending, that might give us something to do in our next nomothetic study, where now instead of just looking at some of those other factors we thought of, now we're going to also focus on the role of peers in offending in old age. All right, so that was our very, very brief tour through different kinds of research and what's the point of research. For most of the rest of this PowerPoint, I'm going to talk about theory and why theory is important and how it fits into science and the scientific method. Theory can be defined as a story about the world, how the world works, or more jargonfully, as a systematic explanation for the observed facts and laws that relate to a particular aspect of life. But in other words, some story or narrative that we've come up with based on systematic observations for how things work. And theory can be really, really, really important. Because what theory does is that it allows us to interpret facts. And everybody can look at the same facts in the world, but depending on your story about how the world works, you can come to incredibly different conclusions, make different predictions, and have different policy suggestions based on your story about how the world works. And I think a really, really important example has to do with how people view disparities in race, especially in the criminal justice system. And this book, I think, was pretty infamous for putting forth a really racist and horrible view of disparities in race and a lot of different things, where they basically said that it's completely inborn and biological, and that's it. Right, so really, really racist, not great interpretation of those facts. On the other hand, most scholars and most researchers would say that of course it has nothing to do with inborn biological differences, and it's completely about how the world is structured and the history of racism and the ways that it keeps being reproduced in existing systems. The important thing here, though, is that the facts are the same, it's the interpretation of those facts that's different. And so you can look at the same numbers, the same disparities, and you can come up with a completely different worldview that can absolutely affect policies and predictions and all sorts of things that matter to how the world works. So this is my soapbox that says theory is important, we should care, but where it really, really matters is in interpreting facts that actually matter in people's lives. And so with that, I'm going to get into some of the boring stuff, which is the anatomy of a theory. So when we talk about theory, we're going to be really talking about two different things. One are concepts. Concepts are abstract elements that represent classes of phenomena within the field of study. So in other words, a concept could be something like age or crime. And these are things that are abstract in the sense that you can't actually go and pick up age or pick up crime and hold it in your hand and look at it. And they represent these broader classes of things that you're interested in. So when we say age, we're talking about the number of years that somebody has on a planet, but often we're also thinking about these more broad groups like older people or younger people. And the same thing as with crime. You could define crime in a lot of different ways. You could look at different kinds of crimes, but when it comes down to it, there's generally going to be a class of things that you're considering crime that you'd be studying here. We have concepts. We also have theoretical statements. And theoretical statements often describe how concepts relate to each other and how we expect them to relate to each other out there in the world. So in our age and crime example, a theoretical statement might be that there's a relationship between someone's age and how much offending they're engaged in. Theoretical statements can also be more general and just state things about the existence of the world or what we expect is true to gird our theory. But most of the time they're going to be statements about how concepts are related to each other. So now we're going to talk a little bit more deeply about these theoretical statements, because there are a whole bunch of different kinds of theoretical statements, but they break down into a couple of categories that are useful to know the differences between. So the first are existence statements. And existence statements are the ones that basically just say what you think is true about the world without really getting into how anything might be related to anything else. So an example of an existence statement in our age and crime example might be that adolescents commit crime. We're not talking about how age is related to crime particularly, we're just saying that out there exist some adolescents who commit crime. That's it. Most research and most theories focus more on relational statements. And relational statements tell us about how different things are related to one another. And there are two kinds of these. The first are associational statements. So an example of an associational statement might be that younger people generally commit more crime. In other words, we're saying that there's some association between age and crime. And if you were to map it all out, do some statistics, you'd find that in general, younger people are committing more crime. The other kind of relational statement is a causal statement. And causal statements are stronger in that they're saying that one thing absolutely causes another thing. So an example of a causal statement would be that getting older causes people to commit less crime, or being young causes people to commit more crime. And in this age and crime example, I think it's a little bit less obvious what the difference is, but we can think about it another way. So let's say that our theory is that being conservative causes someone to support the death penalty. That's a very, very different statement than there is some association between being conservative and supporting the death penalty. Because in that other statement, it could go the other way. Maybe if you support the death penalty, you're more likely to be conservative because conservative politicians are more likely to support the death penalty along with you. But if we're making a causal statement, we're saying that the direction of the relationship is only one way. One thing causes another thing. It's not just related. And this might sound familiar if you've taken any statistics classes. This is the difference between correlation and causation. So two things might be related to each other, but if your theory is making a causal statement, you're saying that one thing is absolutely causing the other thing. So how do we go from theory to knowledge? The answer is the scientific method, or what I'll refer to as the traditional model of science. And you'll notice that this traditional model of science is essentially a deductive model and would probably be nomothetic, but as we'll talk about later in the course, there are other ways of generating knowledge too, and that do not necessarily follow this exact traditional model of science. But let's say we're going to do the traditional model of science. Our first step is going to be to develop a theory, or some expectation about how the world works. And this theory, as I mentioned before, is going to be made up of concepts and theoretical statements. Our expectation about reality is that getting older causes people to commit less crime. So there we'd have our concepts being age and crime, and we'd have a causal theoretical statement, which is that getting older causes people to commit less crime. But now we actually have to test that theory. And the next step can broadly be referred to as operationalization, or putting that theory into some format that can be tested. So one thing that needs to happen is that you have to decide how to measure those concepts. As I mentioned before, concepts are often a bit fuzzy in the sense that they could be defined in different ways or thought about in different ways. When you're actually going to test a theory, though, you have to very systematically decide how you're going to measure those concepts. Something like age is probably straightforward. Most people would agree that years of age is a good way to measure somebody's age. But what about crime? Are we interested in serious crime? Are we interested in any instance of law breaking, including speeding, jaywalking, parking illegally? Are we interested in separating out different types of crimes? And these are all questions that you'd have to answer as a researcher before you could test the theory. And once you've decided how to measure something, how to measure a concept, you'd say that you'd operationalized it, and you could refer to that concept as measured as a variable. So if you were to study crime using age in years and any instance of law breaking, you could then say that age in years is a variable and instances of law breaking would be a variable. So they're your concepts in whatever way you've decided to measure them in your study. You also have to decide how to test your theoretical statement. And a lot of this decision can involve questions about statistics that we're not going to really talk about in this class, but it also involves questions about the more general design of your study that we absolutely will talk about in this class. So for an example here, you might think about testing that theoretical statement that getting older causes people to commit more crime. A simple way to test this might be to look at crime rates among people at different ages, which are what you see in those age crime curves that I showed you earlier. So the decision to test this theoretical statement in a particular way would lead you to develop a hypothesis. And a hypothesis is just a statement about how your variables are going to be related to each other. Essentially the same thing as a theoretical statement. The only difference is that we're now applying it to our concepts as we've actually decided to measure them, and to our study as we've actually decided to do it. And then finally, we will carry out those steps, collect data, and use that data to evaluate our original theory. So one thing that we'll do is we'll actually measure those variables in the way we decided to measure them. And in this case, we might have decided to look at 100 people, measure their age, measure their offending in the past 5 years, maybe using a survey. So however we decided to operationalize the variable, we're now going to go out and collect that data. So we have not only decided how to measure it, we're going to actually measure it. The next thing is to test hypotheses using real-world data. And hypothesis testing essentially means looking to see how the data you've gathered matches with your expectation about reality. Hypothesis testing can also refer to a more formal process within statistics, but here I'm just going to refer to it as using the data you've gathered, comparing it to your expectations about reality, and seeing how well they match. So if you were to gather your sample of 100 people, look at their age, look at their offending history in the last 5 years, if you find that, as you expected, older people tend to commit less crime, you might think of that as support for your theory or your expectation about reality. On the other hand, if you were to collect this sample and you found that everybody was committing crimes all over the place no matter what their age, that would be evidence against your expectation about reality or your theory. So you would have tested those expectations in the form of a hypothesis by comparing the data you get to what you were expecting to happen. There are also a few more terms that we need to go through for variables and hypotheses, and I'm going to just talk about these definitions relatively briefly. So, what's a variable? As we said, a variable is a concept which you've decided to measure in some way. A variable is typically made up of different possible attributes that people, places, objects, or so on can have. So if we're thinking about age as a variable, the attributes that it could have would be different years of age. So age is the variable, and 1 year, 2 years, 3 years, 4 years, 5 years, and so on would be different attributes that that variable could take on. If you're thinking about an offending variable that's have you committed any crimes in the last 5 years, you pretty much have two attributes. One would be, yes, I've committed crimes in the last 5 years, and the other one would be, no, I haven't committed crimes in the last 5 years. But the attributes that a variable can take on are completely dependent on how you decide to measure it. So if, for example, you measured prior offending as the number of times you have committed any crime in the last 5 years, the attributes of that variable would be, say, no crimes, 1 crime, 2 crime, 3 crimes, and so on. So when we talk about a variable, its attributes are just the different values or different characteristics that that variable can take on. And then variables, turning that around, we can define as logical groupings of attributes. So 1 year, 2 year, 3 years, 4 years, 5 years, you group those all together. Logically, it makes sense to call that grouping age. I have offended, I have not offended, you group those things together. Logically, it makes sense to call that offending history. We can also break down a hypothesis into some parts. Generally, a hypothesis is going to involve a statement describing expectations about variables. And this is really similar to a theoretical statement. Again, the only difference is that now we're talking more specifically about the variables as we've decided to conceptualize them and measure them. So in this example, a hypothesis could be that the more years of age somebody has, the less likely it is that they'll have reported offending in the last 5 years. And hypotheses can have the exact same types as theoretical statements. So you could have a hypothesis that would be somebody in our sample will have offended in adolescence, which is similar to that existence statement, which is just that there exist adolescent offenders. And any of those different theoretical statement types that we talked about could also show up as a hypothesis. Again, the only difference is that we're narrowing our lens to look at the study that we're actually doing and the way that things are going to actually be measured. And then in causal hypotheses only, we have two different types of variables that we can talk about. One is the dependent variable. And the dependent variable is going to be a variable that is affected by another variable. In other words, some kind of outcome. The independent variable is going to be a variable that affects another variable or a cause. And I think the best way to think about independent and dependent variables is that independent variables are the cause and dependent variables are the effect. So anytime you're looking at cause and effect in a study, your independent variable is going to be your cause, your dependent variable is going to be your effect. And in independent variables, This can mean a variety of things, including, say, an experimental manipulation. So if I were to run an experiment where I gave half the class a really nice plant to look at while they study, and the other half I didn't give a really nice plant to look at while they study, my independent variable, if I then looked at your studying outcomes, would be whether or not you got a plant. So the variable itself is the experimental manipulation. Did I give you a plant or did I not give you a plant? And in this example, the dependent variable would be how well you did after studying with a plant or without a plant. And that's going to conclude the information I'm going to give to you this lecture. But before I end, I'm going to talk a little bit about this activity that we have due Thursday. And so this is the text of the activity. You can also find it on Blackboard in the folder. You probably also saw it while you were clicking through to this PowerPoint. I'm just going to describe it real quickly. So most of you have probably come across Philip Zimbardo's prison experiment in other classes. I think it shows up in just about every intro crim class, every intro psych class that you can take as an undergrad. So if you haven't, you can look at that website. It has some more information about it. What I'm asking you to do for the activity is to take about half an hour to skim through pages 1 through 18, which is just the introduction and method section of the actual report that was written about the Stanford prison study. You can find the report on Blackboard. It should be in the same folder as everything else. And I want you to look through that report and then try to answer the following questions. So what concepts were they actually studying in the prison experiment? So in their theory about how the world works, what concepts were they interested in? Also, what theoretical statements did they make? In the prison experiment, what theory did they think was going to be relevant to what they were doing? How did they think the concepts were going to be related to each other? Also, how were the concepts operationalized as variables? And with a lot of these, you'll probably be able to find one answer and then find another answer pretty quickly. So what's the concept? And then how did they actually measure that concept in the study? And finally, what specific hypotheses were tested? So we have our theoretical statement, which is very much broad concept about how the world works. And then we have our hypothesis, which is what we think is going to happen in this study that we're doing. So in the Stanford prison experiment, what hypotheses were they actually testing? And I have some more specifics about what I'm expecting from you on the next slide. So each of those questions that I just listed can be answered with between a few words and a few sentences. For the concepts, you can literally just list a couple of words as concepts, and that's totally fine. If it's helpful to write things out in sentences, feel free to do that, but I'm not looking for a lot of information for any of these. And I also want to remind you that these activities are graded based on effort and thoughtfulness, not correctness. I'm asking you to spend about a half an hour doing this. That's not enough time to go through that whole report in great detail and highlight things and think about it and do additional research, because I don't want you to do any of that. I want you to take 30 minutes, see what you can pull out of it in that 30 minutes, and post it up there. This is an activity that I usually do in class. We take about 30 minutes to do it. And so that's all I'm expecting from you now. And so your initial responses to the activity should be posted to the discussion board for lecture activities by this Thursday at midnight. Again, graded on effort. I expect to see a variety of different answers posted. That's usually how this goes because different people will pull different things from it. And then the second part of the activity will be to comment on 2 other students' responses to the activity by the end of the week, which is Sunday at 11:59 p.m. And as I think I've mentioned in other places, comments can either kind of take what somebody's written and run with it. So if they wrote something, you think it's interesting, but it made you think of something else that you saw, you can add that. Or if you disagree with somebody about what the response should be, you can say what you think it should be and then explain your reasoning for it. The comments, I'm expecting no more than a short paragraph, so a couple sentences at most. Again, and I really want to stress, I do not want these activities to take up all week. This is supposed to be the amount of work that you do in a class activity. Please don't do more than that. And I'll go over the answers that I was looking for anyway next week. As you'll see as we go through the semester, some activities will have more clear answers than others. If you have any questions about the activity, remember there will be an optional review session this week, and I have not gotten the survey results back at the time of this recording, but that information will be posted to Blackboard as well.